Hey everybody, welcome to Geometry, Section 4.1, Congruent Figures. So this new chapter is all going to be about proving shapes congruent, which of course means same size and same shape. We're going to focus mainly on triangles, but on this first section we're talking about just figures in general that are congruent. So by the end of this lesson, you should be able to list congruent parts of congruent figures. So that means list all the congruent sides and all the congruent angles. You should be able to write a congruent statement. You need to be able to use a congruent statement in order to list all the congruent parts. And finally, use and understand the third angle theorem. So for vocabulary, congruent polygons are shapes that have congruent corresponding parts. And what that means is I've got this diagram here of a bunch of different congruent polygons. And what that means is every side in this red figure has a side in the blue figure that's exactly the same. Every angle in the red figure has an angle in the blue figure that's congruent to. So every piece in this red shape has another piece in the blue shape that's exactly the same as. So if you can prove that every single piece of this shape is congruent to every single piece of this shape, then you can say that the two figures are indeed congruent. So let's take a look at some of the things that you'll have to do some of the key things that I said you should be able to do by the end of this lesson. Let's check it out. Okay, so let's read the directions here. It says, show that the polygons are congruent by identifying all congruent corresponding parts. Then write a congruent statement. So here's what that means. If I take any part from this first triangle, triangle ABC, let's start with the angles because that's easiest. Let's start with angle A. So angle A is congruent to, and then look over at the other triangle. In this case, angle A would be the same as angle J. And you can tell because they both have that single arc in the angle. Let's move on to angle B. Angle B has the double arc, so that would mean it's congruent to angle K. And then angle C, which has the triple arc, is going to be congruent to angle L. And then let's do the same thing for the sides. So if we start with side AB, which has the single dash in it, then that's going to be congruent to segment KJ. Side BC is congruent to KL. And lastly, side AC is congruent to side JL. So there we go. I've listed all the congruent parts, all three sets of congruent angles, all three sets of congruent sides. If they're four-sided figures, you'd have four sets of congruent angles and four sets of congruent sides. But when it says identify all the corresponding congruent parts, that's what they want, just a big old list of all these congruent things. Last thing, they said, let's write a congruence statement. So a congruence statement says this shape is congruent to that shape. So for the first one, triangle ABC, that's congruent to. Now here's the trick with congruent statements. The first shape, you can name it whatever you want to. You can put the letters in any order. It doesn't really matter. I could have called it triangle BAC, triangle CAB. Doesn't matter. However, whatever order you put it in the first triangle, you have to match that same order in the second triangle. So since I started with angle A, on my second triangle, I'll start with angle J. So triangle J, and then I went from A to B, so that would be J to K, and then to L. So when you make your congruent statement, do your first one however you want, but make sure you follow the exact same pattern in your second triangle. Let's do another example. So again, we can start anywhere that we want. So for problem number 2, let's start with side AB. So side AB has the double dashes. So I look over here to the double dashes, and that's side CD. Next side, let's do AC. AC has the single dash. BD has the single dash. And lastly, in this first triangle, side BC has a triple dash. And then in the other triangle, side BC also has the triple dash. So I'll put BC is congruent to BC. Now, you remember in chapter 2 when we started talking about the reflexive property, and I said, like if it's angle A congruent to angle A, that looks kind of ridiculous. This is where it comes into play. All right, when we're talking about two separate triangles, but they share a common side, yeah, BC in this one triangle is the same as BC in the other triangle. So in this chapter, we're going to get a little bit more into the reflexive property. Let's finish this off with the angles. So angle A is congruent to angle D. Angle B is congruent to, hang on a second, there's more than one angle B. So I cannot write angle B is congruent to anything because I'm not being clear as to which angle B I'm talking about. So if I'm talking about angle B in the first triangle, I need to call it angle ABC. Or I could have called it CBA. Doesn't matter. Either way, I'm looking at the second or the double arc. So in the second triangle, the double arc is right here at C. So I would say angle DCB or BCD, doesn't really matter. So I've knocked out the single arc, I've knocked out the double arc. Now let's hit the triple arc. So for the ones with the triple arc, that's angle C, but I got to use 3 letters. So ACB. And the triple arc one over here is CBD. Okay, now let's make this congruent statement. It can be, the first triangle can be in any order. So I'll just say, I'll say ABC. Just for the sheer fact I'm going from single arc to double arc to triple arc. So if I follow that same pattern in the second triangle, single arc, double arc, triple arc, that's going to be DCB. All right? Hopefully that makes sense. Now we've done 2 pretty good examples. I'm not going to bother you guys with the third one. Let's scroll on down and take a look at this one. Can we list all the congruent parts for this one without a diagram? Okay, what if we just have a bunch of letters, a congruence statement, if you will? How can I list all the congruent parts? Well, first off, I noticed that in this congruent statement, there's 4 letters, which tells me it's a 4-sided figure. So when I list this, I'm going to have to list 4 sets of sides and 4 sets of angles. Let's start with the angles first, because that's probably going to be easier. And here's how you can do it even without a diagram. Remember that the order matters. So when I had angle A, that should be the same as angle C. And then angle B should be the same as angle D. And then the third letter is G. So that should be the same as angle E. And the last letter is H. So that should match angle F. So there I listed all the angles without even seeing a diagram. Okay? So that's why order matters when you're making your congruence statement. So now let's go ahead and do the sides. So I'm going to start with side AB. And you probably picked up on this already, but if I use the first two letters, then I got to use the first two letters in the other one. So CD. If I do BG next, the two middle letters, I got to use the two middle letters over here. So DE. The last two letters are GH. So GH is going to be congruent to EF. But remember, there's four sides. So the side that I haven't gotten is AH. And that's going to be congruent to CF. So even if you don't have a picture, as long as you've got a good congruent statement, you can list all the congruent parts. Now here's a practical application of it. Here we have two congruent figures. How can I find the missing angles based off of these two congruent figures? So question 3 says find the value of x. Well, x is going to be right here with angle A. So which is going to be matched up with that? That would be angle P. It's the same shape, just flipped upside down. So I could write the equation 2x plus 4 equals 100. Subtract 4 and you get 96, and then divide by 2 and you get 48. So x equals 48. Let's do the same thing for y. Let's see. The base here is 3y minus 3, and then the bigger base on the other side is 12. So I'd say 3y minus 3 equals 12. Add 3 to both sides, you get 15. Divide by 3, and you get y equals 5. Hopefully that makes a lot of sense. Let's move on to the third angle theorem. The third angle theorem says that if two angles in one triangle are congruent to two angles in another triangle, then the third angles must be congruent to each other. So in this diagram, I know that angle A is congruent to angle D, angle B is congruent to angle E. So the third angle theorem tells me that angle C has to be congruent to angle F. Seem easy enough? Let's try an example. So here in this triangle, I've got one angle being 55, another angle being 65. Can I use that to figure out angle M? Well, if I add those up, that's 120. 120 from 180 is 60. So now can I use that with what we just talked about and say that this 60 degrees is going to be the same as 2x plus 30? And then I can use that equation to solve for x. Subtract the 30, divide by 2, and there we go. X equals 15. Now let's move on to a proof. Okay? This one looks big, bad, nasty, and ugly, but let's just walk through it. It won't be that bad. So it says, given AD is congruent to CB, and we've got all this stuff marked. DC is congruent to BA. Angle ACD is congruent to angle CAB. Angle CAD is congruent to angle ACB. How can we prove that these two triangles are congruent? Well, as of right now, the only way that we can prove that the two triangles are congruent is by listing every single piece of information and saying all 6 of these pieces of information are congruent. Therefore, the triangles have to be congruent. So it looks like so far we have 2 sets of sides and 2 sets of angles marked congruent just from the given. How can we use the remaining information to figure out that these two triangles are congruent? So let's take a look at the sides. Well, it looks like these two triangles share a common side, so that AC in the left triangle is exactly the same as AC in the right triangle. So what I can do is I can add step 2 and say AC from one triangle is congruent to AC in the other triangle. And my reason I know that? Reflexive property. So I'll go ahead and mark that in the diagram. So now I have it on record that I've got 3 sets of congruent sides, and I need that third angle. Well, hey, that's what we just talked about. If you know that 2 angles in one triangle are congruent to 2 angles in the other triangle, then the third angles have to be congruent. So step 3 is angle D is congruent to angle B by the third angle theorem. So now I have it on record in the proof that all 3 sides in one triangle are congruent to all 3 sides in the other. All 3 angles in one triangle are congruent to all 3 angles in the other. So I have listed all 6 pieces of information here. So I can now say that triangle ACD is congruent to triangle CAB. And you won't really need to know this reason. Okay, the rest of the chapter is all about shortcuts. But all corresponding parts are congruent. All right. So the main reason I wanted to show this to you is so that you could see the reflexive property used in action in a proof, also the third angle theorem. Okay, and I'll be real honest, the third angle theorem is not something we use a ton, but it's just good to know. So that's our lesson. If you guys have any questions, please feel free to email me or ask me in class, and hopefully this new chapter will be all right for you guys. Have a good one.